In this video, we're going to talk about ionization. Now, to start, we're going to talk about valence electrons. Valence electrons are really what's behind ionization. And these are the electrons found in the outermost energy level. These include electrons in both p and s orbitals. So here we have the electron configuration and a Bohr diagram for nitrogen. So if you look at the Bohr diagram, we have 2 electrons on the inner level. Those are inner or core electrons. And then we have 5 electrons on the last or outermost energy level. Okay, so we have 5 there. And if you look at the electron configuration, this goes to the second energy level. So we have 2p and 2s. So if we add those 2 exponents together, we get 5, which corresponds to the 5 electrons that are in the outermost energy level. Those are the valence electrons. Okay, so we only are concerned with the electrons in the outermost energy level when we're talking about ionization. So, on the periodic table is numbered a variety of different ways, but for the periodic table that we use in class, we're looking for the group number that has an A next to it. So this is 1A, this is 2A, we have some B's in the middle, and then it picks up 3A, 4A, 5A, 6A, 7A, and then 8A. Right? So the number in front of the A tells you how many valence electrons you have. So from 1 all the way on the left side to 8 all the way on the right side. Okay. Now, there is one exception, and that is helium. If you look at helium as circled on here, helium only has 2. And we'll get to that in just a second. So, example 1 says, determine the number of valence electrons for the following atoms. So let's start with potassium, and I'm going to be flipping back and forth here. So potassium is right here. It's in the first group, so it has 1 valence electron. Oxygen, we go and look at our periodic table. Oxygen is right here. It's in group 6A, so it has 6 valence electrons. Aluminum is right here. Aluminum is in group 3A, so it has 3 valence electrons. Okay, pretty straightforward. Now the noble gases are found in group 8A or group 18, depending on how your periodic table is numbered. Noble gases have a full outer shell of valence electrons. They are extremely stable. Now, if you remember, I said that helium is kind of an exception here because helium only has 2. Okay, so helium only has that first energy level. And if you remember, if we draw out a Bohr diagram, that first energy level only holds 2 electrons. So to be completely full on that first energy level, you only need 2 valence electrons. For the other atoms in group 8, they're going to have at least 2, and they are going to have a full outer shell, which would be 8 on the second row, but 8 valence electrons is what we're looking for. Okay, so helium only needs 2 to fill up that first one, and then everyone else will have 8 in that outer shell. So again, since it's already full, it's extremely stable. So everybody wants to be like the noble gases because they're stable. So atoms are going to do whatever it takes to get a full outer shell, whether that's to gain the number of electrons they need to get to 8, or to lose electrons so that they can, kind of like peeling an onion, get rid of the partially filled outer shell to get to a full outer shell below. Okay, so to determine the charge, we first look at the number of valence electrons. Then we determine if the atom will gain or lose. If it has between 1 and 3, rather 1 and 4, it will lose electrons to form a positive ion. If it's 4 to 7, it will gain to form a negative ion. And if you look, 8 is not on there because 8 already has a full outer shell. So let's take a look at sulfur. Sulfur is right here. It's in group 6A, so it has 6 valence electrons. To get to 8, it's going to gain 2. If you gain 2 more electrons, your charge will be -2. You now have 2 more protons than electrons. Let's look at chlorine. Chlorine is in group 7A. It has 7 valence electrons. It only needs to gain 1 to get to 8. If I gain 1 electron, I'm going to have a charge of -1. I now have 1 more electron than protons. All right, aluminum is in group 3A. It's going to have 3 valence electrons. Now, this is where it gets a little confusing when we lose. So how can you lose and have a full outer shell? Well, let me show you what I mean. So let me just draw an atom here. Do it with 3. And then let's fill this in. So here's our first one, our second one. Okay, and then I said we had 3. So let's fill these in. 1, 2, 3. Okay, and our goal is to have a full outer shell. So how can you lose electrons and have a full outer shell? Well, watch what happens. So if I get rid of my 3 electrons, I will get rid of that outer layer, and now, kind of like peeling an onion, I have a full outer shell below what was a partially filled layer. So that is how you end up with a full outer shell by losing. Now, it seems a little backwards. So we are going to lose those 3 electrons. If I lose 3 electrons, I will now have a positive 3 charge because I now have more protons than electrons. All right, and then potassium. Potassium is in group 1. It has 1 valence electron, and it will lose that 1 valence electron, ending up with a positive 1 charge. All right, so that is how charges work. So let's do a couple of examples. All right, in this example, it says the electric configuration of a sodium ion is 1s2, 2s2, 2p6. So here we have 2, 4, 6. Plus 4 would be 10. So we have 10 electrons. And if you go and look at sodium, sodium Na normally has 11. So it lost an electron. If you lose an electron, you will have a positive 1 charge. Here it said which ion would most likely form the following electron configuration. Okay. So let's see, we have 2, 4, 10, 12, 15. So if we go and find 15 on the periodic table, that is phosphorus. Phosphorus. Okay, phosphorus has 5 valence electrons, and you can even see that in the electron configuration here. 2 plus 3 is 5. And to get to 8, it needs to gain 3. So if I gain 3 electrons, my charge will be -3. This says which ion would most likely form from the following electron configuration. So we have, let's see, 2, 4, 10, 12. We have 12 electrons, which is magnesium, Mg. Magnesium wants to lose 2 electrons to get to that outer shell. So if I lose 2 electrons, I will now have 2 more protons, and my charge will be +2. That is ionization.